Hello everyone, welcome to Physics Pathfinder. In today's video, you will be finding Theme C based past paper questions from Ibdp. These are based on wave mechanics and it is covering May 2024, both the time zones. So let's start. If you look at the question, an object is undergoing simple harmonic motion. For this object, what is the phase difference between the variation of displacement with time and variation of acceleration versus time? So if you remember, for SHM, we already know the equation that A is proportional to minus of x. That is, acceleration is proportional to displacement, but in opposite direction, which literally means that if x is a sine function, then A should be a negative sine function, which means x is a positive sign and A is a negative sign, which is like a mirror image of each other. That means it is 180-degree out of phase and 180-degree is pi radians. So the answer is D. Going to the next sum. A string which is vibrating at both ends. The frequency of the second harmonic of a stationary wave generated in this string is 240. What is the frequency of the fifth harmonic? So for this, you have to understand when the loop is attached at both ends, you have nodes at the two ends where it is attached and an antinode in between. So the basic frequency equation is Fn, which is n is an integer, is equal to n into V over 2L. This is kind of the master formula where you can see n is an integer. Based on the frequency, we can put the value of n. For example, if n is 1, the first frequency will be V over 2L. And as given in the question, the second frequency, which is 2V over 2L, 2 cancels out, so it is V over L. And V over L is given as 240 Hertz. V over L is 240. So what will be the frequency for fifth harmonic? F5, just replace N as 5 here. So it is 5E over 2L. And if you compare V over L to 5E over 2L, that is, if you divide F5 by F1, it is 5 by 2 V over L multiplied by L over V. And that gives you the answer 2.5 times, which basically means the fifth frequency is 2.5 times the second frequency. So if my second frequency is 240, the fifth frequency will be 240 times 2.5, which is 600 Hertz. So the answer is C. Let's go to the next. A longitudinal wave that travels along a horizontal spring. The frequency of the wave is given to you. It is 4 Hertz frequency. And the speed of the wave is 2 meters per second. What is true about the particle? Particle changes direction 4 times every second. Is it that it moves in phase with the particle 0.2 meters away? This is something we can relate to because frequency is inverse of time. Therefore, time period is inverse of frequency, which means 1 over 4 and 1/4 is 0.25 seconds. So the answer is C. An object performs simple harmonic motion when the displacement of an object is half the amplitude. So the sign x0 is for amplitude, but here in this case it is half of amplitude. The kinetic energy of the object is given as E. What is the total energy? So if you observe this situation, this is the pendulum in the mean position. This is the pendulum in its extreme position. And at extreme position, it has maximum amplitude, which is x0. But if I tell you, if we talk about the energy at the extreme position, you see energy at the extreme position is entirely potential energy. Potential energy is entirely there at the extreme, and at the mean position, it is kinetic energy. And kinetic energy is given by the formula half m v square. So if I use the formula V is equal to R omega, here the maximum displacement, which is the amplitude or the radius of the circular path, is nothing but x0. So instead of V, we are going to substitute it as amplitude into the angular frequency. So that would be half m omega square x0 square is the highest kinetic energy at the mean position, EK. And EP will also have the maximum value. That is, EP is also half m omega square x0 square. Numerically, it will have the same value. Okay, that is kinetic energy at the mean position is equal to potential energy at the extreme position. Now, according to this question, if you can see, the displacement is not x0, but it is half of x0. So we'll go back and change the amplitude to half of x0, which is x0 over 2. So what will be the change in kinetic energy? Kinetic energy, which was initially half m omega square x0 square, will now become half m omega square x0 square by 4. And this value of kinetic energy is given as E in the question. Kinetic energy at an amplitude of x0 by 2 will have the energy E. Okay, so if I'm trying to calculate the total energy should be E kinetic plus E potential. So if you look at this equation, if the total energy is a whole as 1, and out of this, if you can see, the energy that is occupied by kinetic is 1/4. So if I see this is the total energy, there is an extra 1/4 in this, which means your kinetic energy is actually occupying 1/4 of the total energy. So if kinetic energy is applying one-fourth of the total energy, therefore potential energy will be occupying the rest, which is three-fourth of total energy. And in this question, one-fourth of total energy is given as E. One-fourth of total energy is given as E. What will be one-fourth of total energy? This part is E. If this part is E, then potential energy will just be E by 3. If potential energy is going to occupy part E by 3, you can see carefully, just replace E, E total by 4 by E. If I replace E total by 4 by E and divide this by 3, what will I get? Let's see again. E is nothing but one-fourth of half m omega square x0 square. If you divide this by 3, what will happen? This 3 will go on the top, and that becomes three-fourth. So your potential energy is three-fourth of the total energy. So when I would like to find the total, I just add both, and this gives me 4E by 3 as the total energy. So your total energy is the share of kinetic plus potential. Kinetic is E as per the question. So potential should be E by 3, which gives you the option B. Let's now go to the next question. Light of wavelength 400 nanometers is incident on a diffraction grating normally. So you know the wavelength and you know the angle. The slit separation is 1 micrometer. What is the greatest number of maxima that can be observed? So according to grating equation, 2d sine theta is equal to n lambda. 2 times d is the slit separation, which is 1 micrometer. Sine theta is sine 90, which is 1. N is what you have to find, and the wavelength is 400 nanometers. So basically it is 2 into 10 to the power minus 6 over 400 into 10 to the power minus 9. So this should be around half into 10 to the power minus 1. Then taken up, it will be 10 to the power 1, which is 5 slits. 5. You will find 5 maximas in the phone M. Let's do the next question. A microphone M is on a moving train, detects the sound from a loudspeaker L that is placed on the track. L emits a sound of a constant frequency. So L is the source, which is on the track of a constant frequency F. Frequency detected by M, which is the source, is continuously decreasing. That is, the source is detecting a frequency which is continuously reducing. The train is moving. So if we look at the equation where you have a moving observer and the frequency is reducing, which actually tells you that the train is moving away. So we can see it's V upon V plus UO, which is the speed of the train. Okay, now what will cause a lowering of this frequency? Lowering of this frequency is when the value of V plus UO goes on increasing. And for that to increase, UO should be constantly increasing. If it is increasing, what is increasing is the speed of the train. So the train is moving away from the speaker at an increasing speed. Answer is A. Let's go to the next question. Radio waves are emitted spherically from a source. At a distance d from the source, the amplitude of the wave is x. What is the amplitude at a distance 2d from the source? So first we already know that intensity is directly proportional to the square of amplitude. So in this case, it is square of x. We know this. We also know that intensity is inversely proportional to the distance of the spherical wavefront, or distance of the, we already know for this question, you already know that intensity is directly proportional to square of amplitude and inversely proportional to the square of distance from the source. Why is it so? Intensity is basically power. Power is energy emitted. Intensity is the power emitted per unit area. So we already know that intensity is defined as power emitted per unit area. So for a constant power, we can tell that the area that it's going to cover is 4 pi r square because it's a spherical wavefront. So if the distance to the source is d, then intensity is inversely proportional to d square. So looking at these two equations, we can also tell that amplitude is inversely proportional to the distance. So if the distance is doubled, amplitude should go half. So it will become B. B is the answer. Next question. Equilibrium position of 6 particles in a medium are separated by distance 2 centimeter as shown. So when a particle is in equilibrium, its position is, as you can see, this is the equilibrium position. The position of these particles when a longitudinal wave is emitted through the medium is changing. So very clearly you can see the position of 0, 4, 8 doesn't change, which means that 0 is the center of rarefaction, 4 is the center of compression, 8 again is the center of rarefaction. And distance between two particles in same phase is one wavelength. So one wavelength is the distance between 0 and 8, which is 8 centimeters. So your answer is D. Let's go to the last question for today. Light passes from a medium. So there is a medium which is a denser medium than air. So it's going from denser to a rarer medium. Critical angle is theta c, which expression gives you the speed of light in the medium. So the light is entering from a denser medium to a rarer medium. It is incident at an angle theta critical here. They are asking you the expression for light in the medium. So we know that if this is first medium and this is second medium, Snell's law tells you n1 sine of angle of incidence is equal to n2 times sine of angle of refraction. N1 is something we don't know. Sine of theta critical is the angle of incidence. N2 is air. So we should know that refractive index of air is 1. And sine of R is sine 90, which is also 1. So your theta critical is nothing but sine inverse of 1 over n1. Or sine of theta critical is 1 over n1. Now, as per the definition of refractive index, n1 is nothing but speed of light in air upon speed of light in a given media. So if we make V as the subject, n1 will be shifted on the other side, so it will become C over n1 is V. So if we rewrite this equation for sine of theta critical is equal to 1 over n1, replace 1 over n1 in this equation. If you replace 1 over n1 as the subject, then that is V by C. So instead of 1 over n1, I can write sine of theta critical is equal to V by C. Therefore, V is equal to C into sine of theta critical. So your answer is D. So in my next video, you will see the theory section, that is paper 2 for May 2024, time zone 1 and time zone 2. See you.